Alright, so I'm going to look at some new things from yesterday and then today. Kind of go over some notes here. So we looked at powers of the power, but we had fractions. So we had something that was like 3 to the second power over 7 to the third power. Okay. So, and then we would also now put this to the power of 3. My 3 is coming out a little funky here. There you go. Perfect. So then our rule of power to power is simple, that you would multiply your exponents, right? And then same, because this is also power of power, nothing changes. To go a little more in depth with this, like I did during our lesson, we could break this down and say that this is technically 3 groups of 3 to the second power times 3 to the second power times 3 to the second power here, right? And then this is over 3 groups of 7 to the third power times 7 to the third power times 7 to the third power, right? And then we want to make sure that we now put this into a single exponent form. So we can then, 2 rules. One rule, for the rule of power to power, you multiply your exponents. So this would be 3 to the 6th, and you multiply your exponent, this would be 7 to the 9th. Another rule that we're looking at when you see the expanded form of this is where you're multiplying exponents when you have the same base. So since I have all these 3's that are the same, I'm going to add my exponents. All right. Same base, no matter what the exponent is, you add. Okay, so then this becomes 3 to the 6th power over 7 to the 9th power. Ooh, that's not 79. 7 to the 9th, 7 to the 9th power. Okay, and if you were to do the math on this, whether it's the expanded form like this, whether it's the singular form here, whether it's the original expression, we'll end up with the exact same number. Okay, so this is your original problem you might have. This is the expanded form. This is a singular exponent or single power form. Okay. So I'm going to clear all this. The next thing we have the next thing we're going to look at is fractions with exponents. So simple, 4 to the 8th power over 4 to the 4th power. Now remember, when we have addition, when we have a multiplication, so if I had same base, different exponents, didn't matter, right? I'm going to be adding. So this is equal to 4 to the 12th. But now, since that we're doing division, we're doing the opposite. The opposite of multiplication is division. The opposite of addition is subtraction. So whenever you have exponents or fractions that are dividing, you're going to subtract your exponents. So now this will become minus 4. Okay, so this is going to equal 4 to the 4th power. Okay, so I take this up here, I subtract it, right? My bases are the same. This now becomes 4 to the 4th power. Next, we'll look at some negative exponents. Let's say I had 5 to the negative 3rd power. Remember, when you have a whole number, If you write a whole number as a fraction, it's usually that number over 1, because that number divided by 1 is going to be itself, right? And so when we look at it like this, we're thinking the reciprocal, the opposite of 5 to the negative third over 1, is simply going to be 1 over 5 to the third. Okay, the reciprocal. And that changes the sign from negative to positive. Okay. Next, we're going to go to same exponent, different bases. Let's say I had something like 5 to the second power times 6 to the second power. Okay. This is saying that I have two groups of 5, two groups of 6, right? So I'm going to expand this first. This is going to be 5 times 5 times 6 times 6. If I look at it like this, I have this group of 5 times 6. I have this group of 5 times 6, right? I have two groups of 5 times 6. So I can actually condense this and rewrite this again as 5 times 6 to the second power. And then, once again, you follow your PEMDAS, your orders of operation, right? This is then going to be equal to, do 6 times 5, which is 30. And this is going to be to the second power. So you see your exponent never changes. It stays that same number. I'm not adding and combining those because I have two separate base numbers, right? I have this base and this base, which are not the same, right? But I know I'm doing the same operation twice for each one, right? So because I'm multiplying those two together, once again, like I said, you have two groups of 5 times 6. You can have 30 times 30. Either way, it's going to be the exact same number. All right, another one we have. Let's go for some negative numbers here again. We'll do two more. Negative number, let's say we have 4 to the 12th power. Oh, sorry, 4 twelfths to the negative third power, right? So the same thing, your numerator and denominator are going to be flipped. They're going to become the reciprocal due to the fact that this is negative, so I need to change. This is now going to be 12 to the 4th, sorry, 12 over 4 to the third power, okay? So if you ever have a fraction that is to the negative exponent, negative power, you're going to have the reciprocal of that fraction to the positive exponent, all right? So I flip my fractions, numerator and denominator change places, which then allows and causes my negative exponent to, or negative power to, become positive. All right. And then let's say we had something like, sticking with net, let's go negative still, 4 to negative 6 times 4, 11. This is very simple because we have the same base. We have different exponents. It doesn't matter. There's one rule when you're multiplying two bases that are the same. All right. 4 is the same here, so I don't change that. I do, on the other hand, add my exponent. So even though it's negative, a negative exponent, I don't need to flip it because I need to combine these first to get rid of this negative sign. Now, if I add those together and it's still negative, and I'll show you that later. So this would be simply 4 to the 5th. Okay. But let's say perhaps I had 4 times, sorry, 4 to the negative 11th power, right, times 4 to the 6th. Yes, we're still going to follow our rule and add. We're going to add. But a negative 11 plus 6 is still going to give us a negative number. This will end up being 4 negative fifths, which then in this case you would have to take this number and you would have to remember this is over 1, so this now would become 1 over 4 to the 5th power. Alright, so you do your first rule, your number 1 rule first when you have when you're multiplying the same base. You add your exponents, right? And then after that, if your exponent is still negative, you then need to take the steps to have that reciprocal there, right? And it goes vice versa. If I wanted to turn this back into negative, I would flip it, right? And I'll kind of go back over. We'll do the power of power rules. Basic 3 to the 2nd power. Right, so simple power to power rule, we multiply those. That now becomes 3 to the 6th power. That's a simple, right? Basic, if you're dividing, I had 3 to the 2nd power divided by 3. Let's change this up, make this a little different here. Let's have 4 to the 5th power divided by, let's say, to the 3rd power. I can't get that one out. 4 to the 3rd power. Simply going to subtract, right? This becomes 4 to the 2nd. Simple, right? Basic. Different bases. So I showed you that.